Hey everybody, welcome. Finally, little delay there. Sorry about that. These things happen. To the EarthSky Monday live stream. We've got an exciting topic today. Today we are going to be talking to Davide Faranda, and he's the director of climate research. I'll get to that. I'll give you the specifics on him. But what he really does is run an organization, Climameter.org, and he compares what a world without climate change looks to what we're living in. And he tells us how much that effect is. He can quantify that effect for us. Interesting stuff. But before we get to that, we have a couple of news items. And so here's Debbie Bird with the news. Come on in, Debbie.
Hey. Hi.
Good evening.
Wow, what an exciting morning we've had. Cam, can I have the first slide, please? So just over an hour ago, we had the successful launch of NASA's Europa Clipper spacecraft, and it's now on a path that'll carry it to Jupiter's large ocean moon, Europa. It blasted off from Kennedy Space Center at 12:06 p.m. Eastern. It's going to take 6 years to get to Jupiter, and it'll travel 1.8 billion miles. Once there, it'll focus on Europa, which is the second moon outward of Jupiter's 4 large Galilean moons, and it'll delve into Europa's mysterious global ocean, which is thought to contain twice as much water as all of Earth's oceans, but it's hidden beneath this moon's icy crust. So that's Europa Clipper on its way to Jupiter.
All right. 6 years.
But there's more.
Plus. There's more. What else do you have? Now,
Kim, next slide, please. Okay. You may have heard that there's a comet in the sky, and this comet, we're calling it A3, and it's in the west after sunset. I just heard this morning that this is the brightest comet since Hale-Bopp in 1997. So I could see Hale-Bopp from my home in downtown Austin, Texas. I could see it from my neighborhood downtown. So that's like pretty amazing. This planet is, as I said, west after sunset. It's moving up day by day. It's moving above and to the right of a very bright planet that's also in the west, and that's the planet Venus. Next slide, please. And since yesterday, we've been receiving these exciting photos, which are of the comet's anti-tail. So you can see that comet tail shooting upward away from the horizon. But if you look really closely, you can see there's another tail that's pointing down toward the horizon. Crazy, huh? I've never actually seen one of those. And that's the anti-tail. It's the anti-tail. It's very rare to see it. So this image is from Eurelys Medina in Puerto Rico, and a comet's tail usually does point away from the sun. But yesterday, today, and tomorrow, we're passing through the plane of the comet's orbit. So we're seeing this anti-tail pointing toward the sun. Next slide, please. And here's just a little annotation in case you couldn't see it on the other one. What's cool about this anti-tail, Dave, is that it shows you where the comet came from. So the stuff where it's been. So the stuff in that anti-tail is like the cometary debris, the icy particles that, if we encountered them in space, would make a meteor shower.
Oh. Okay, something to look
Crazy,
forward to.
Huh?
But we're not going to see a meteor shower because this is not an Earth crosser.
Right? We're not going through the debris from this comet, but it's really cool to see this process happening where this comet is actually making this debris and leaving it behind in its orbit. And I mean, we've been talking about that for 50 years, that the comets leave behind, litter their orbits with icy debris, and that's what makes meteor showers. And here we are seeing it in our sky.
And you can see it in your sky. So go out tonight, look west, just after sunset, find Venus, look up and to the right. I found it last night, and I didn't need any help to see it. It was very dim, but I had my binoculars, swept them around, found it. Beautiful to look at. The darker
Don't miss
your
this
sky,
one.
no, don't miss this one. But the darker your sky, the better the view. Thanks, Debbie. Got anything else? We're going to see
That's
you on
it.
Friday, won't we? No, we'll see you on Friday, won't we?
Yes.
Yes,
Sun
we'll
News
be
on Friday.
on Friday. That's 12:15 Central Time. And you can get your Sun News Daily Dose at earthsky.org and our newsletter. All right. Thanks, Debbie. Appreciate it. See you next time.
Bye.
Bye. Okay, folks, it is time for us to bring out our main guest today, the main man, and that is Davide Faranda. And Davide is, hey, how are you? How are you doing today?
I'm fine. Thanks for the invitation. I'm doing great.
Oh, I'm glad that we could finally connect. We tried to connect earlier with Davide and had a bit of an issue, but we've conquered the issue. We almost had another issue today. Anyway, Davide is the research director in climate physics at the Laboratoire. I'm trying to do this correctly. I'm going to slaughter it, so I apologize to any francophones out there. Laboratoire de sciences du climat et de l'environnement at the Institut Pierre-Simon Laplace at the French National Center for Scientific Research. And Davide's expertise is in extreme weather events. So we're talking about cold spells, heat waves, cyclones, severe thunderstorms, all that kind of stuff. But specifically, what he can tell us is how much the climate change we've seen in recent years affects the weather we're seeing today as compared to if there were no climate change. And I think that is pretty significant a thing. So, David, welcome. Welcome. How are you today? How is the weather in Paris?
I'm doing fine. I'm doing great. And the weather is cloudy. For you, it's morning. Here, it's already in the evening. There is no more sunlight. But it's going to be hard to see the comet with the lightnings. La ville lumière, too many lights.
Mm-hmm. Yes. Well, perhaps tomorrow. So, Climameter is a tool that you constructed to help people understand climate change and how it changes our weather. How did you get involved in wanting to understand that?
Yeah, it's a very long story. I was passionate about meteorology since I was a child. I grew up in Sicily, in Italy, and one of the first memories I have is like looking at the sky, not really at night, but like when there were thunderstorms. Like that was what was fascinating me. And then I decided to study meteorology, but it was like a sort of call, these kind of things that you have to do. And I didn't have any doubt about it. So I studied physics because that's the way you get to understand these phenomena. And I studied that in northern Italy, in Bologna, the city for the Bolognese.
For the Bolognese.
Yes, right.
Delicious Bolognese.
There is also the most ancient university in the Europe, at least in the Western world. So a university that was founded like 1,000 years ago. And then I moved to Germany, England, and now France. And I did PhD thesis in statistics because as you mentioned, when we want to study one event, for example, a tropical cyclone, what we have to do is we have to compare with similar events. And to do this, we need tool from statistics, but we also need the understanding from the physics of what are these phenomena that we want to study. And then back in 2015, I came to France and I started to work here at the National Center for Scientific Research. And I start to get interest in this science that is called attribution, which means basically, it was a very young science when I began. Basically, the idea of attribution is like to really understand what's the role of burning fossil fuels in a weather extreme event, whether the greenhouse gases emissions can change the frequency of the intensity or both of the events that we are living on Earth as extreme meteorological phenomena.
So and what did you find out? What did you discover when you looked?
Yeah, so the idea was that at the beginning, when I started to work on these topics in like 10 years ago, there was a framework that allowed for statistical analysis of the events. which means like you were comparing basically the probability of exceeding a certain value of precipitation, of temperature, or wind. That's kind of things that we do in engineer when we want to know whether our bridge will be still there if we have a tornado or a tropical cyclone or hurricane wind force. We have to construct the bridge to sustain certain thresholds of variables. That's what we do. And so the things that we're doing, my colleagues were understanding basically before I start whether this threshold changes with climate change, okay? But then the idea is that it's just a single value, like just one value for an entire weather phenomenon. But as you know, now we had Hurricane Milton or Hurricane Ellen in the US, and you know that the wind field is very different if you are in Tampa or if you are in Miami or if you are in like inland, and the phenomenon itself is a very complex structure, right? So
extremely complicated.
Yeah, right. So the idea in my research was to bring in this complexity, that is like bring the idea that we are not just looking at single values, but we're looking at weather phenomena, rather than understanding how precipitation or wind associated with a tropical cyclone was changing. The question I asked was, is the tropical cyclone changing in its structure, right? So, and how this is changing with climate change. It's different than ask just how rain or wind is changing, because you can have rain or wind, for example, for thunderstorm, or because you have a large storm that comes from the north, from the poles. So the idea in my research is really to go from the level of the hazard. The hazard is rain, wind, high temperature, low temperature, to move it back to the phenomenon that is producing the hazard, so the cyclone. And that's the idea that is at the basic of the tool that I've developed, that is a Climameter.
Right.
That is this tool that now allow us to do in a very quick way and scientifically sound this attribution for weather phenomena. And I just give you the last examples, the two examples that concern more your folks in the US are the Hurricane Ellen and Hurricane Milton. So if you go on www.climameter.org, then what you will see is that, not surprisingly, you've heard this in the news. It's also what we used to say when there is now a tropical cyclone that hit the US, is that climate change has played a role in intensifying the cyclones. And for the last two that we have analyzed, we have seen that there is a contribution of increasing the precipitation and increasing the winds. But this contribution is different if we look at Hurricane Ellen and Hurricane Milton, which means that each cyclone is like individual for us. It's like you think that we are doing sort of a medicine. Like you go to the doctor and you say like, okay, sorry, today I feel like I have a cyclone, right? And the doctor like says, the doctor will say like, can you describe this cyclone? How do you feel your cyclone is?
The cyclone hurts when I touch right here.
Exactly. So you describe the symptoms, and then the doctor makes some diagnosis that say like, okay, you are suffering from climate change, and climate change is causing for you these kind of effects. So each individual, each disease, it's different. So that's why we have to perform attribution studies. We cannot just say climate change is intensifying cyclones. We want to know how, and we want to know why. And that's the kind of answer that Climameter provides.
So if I went in with my condition to my doctor and I've said, I've got a bad cyclone here in my left shoulder, he can say, well, I think it's because you were lifting that thing last week and that contributed probably 10%, but you already have a persistent injury here. This would have happened anyway, but you made it worse, Dave. What were you doing lifting above 10 pounds? I told you. So that's what we get at Climameter. And by the way, I hope everybody can see that. I've got the Climameter link up on our screen now, climameter.org. So you can basically say Milton had a contribution from climate change at a certain percentage, right? Or an intensity.
Yes. But
you can put a definitive number on it.
Yeah, but the number is a number that is different for each geographical point of the map. So we can make map of change. So that's, I think that's the unique feature of Climameter with respect to the other consortia that perform attribution. We can go and talk and really analyze what happened in Tampa, what happened in Fort Myers. We can really go at the level of the cities and provide changes that then are useful to dimension the infrastructure, to understand what was wrong, for example, or could be improved with the evacuation plans, and how and what's and the other things that allows Climameter is exactly what you were saying, quantifying. Is it all climate change, or it's there is a part of the natural climate variability? And so this is different for different phenomena. So, for example, what we have found that for Hurricane Helene, we had a lower contribution of natural variability. That means, like, for example, El Nino, how the ocean is warm or cold, which kind of phases we are going through, and the stronger contribution from anthropogenic climate change.
Meaning
for Milton,
human-caused climate change.
Human-caused climate change. For Milton, it's so exceptional, the trajectory that the hurricane
it was unusual. It came across the Yucatan Peninsula and then through the...
Indeed. That's already to say this assessment, to make this assessment is first more difficult, and then we cannot exclude that the natural climate variability played a role in devising sort of for the hurricane this trajectory, right? So in Climameter, there is all this granularity. The world is not black or white. Climate change is a scale of gray that is going towards black, unfortunately, because what we see is that we have that for the extreme events that we cover, we have a clear signature of the fact that we are burning fossil fuel is making our climate more extremes. And we see this, we have analyzed so far about 60 events, and for 55, we see a strong signature of anthropogenic climate change. So that's to go back to your example of the doctor. It's like, you know, if we talk about symptoms as extreme events and climate change as the disease, for example, a cancer, okay? It's like 20 years ago, we already had cancer because we were burning fossil fuels, right? And my colleagues of the IPCC at that time, they were already saying, look, that's going to be bad.
Yes.
20 years ago. And now what we go to the doctor again. The doctor is now Climameter, for example, and the doctor say like, you got 20, it's getting 20% bad, 30% bad, worse. So what are you going to do for this, right? So that's the question. The doctor, when you know that you have a cancer, you don't cure your symptoms, right? Curing symptoms will be the equivalent of doing evacuation in Florida, like, okay?
Right.
That's really...
You want to treat the disease's core, not just the outfalling symptoms.
Exactly. And
how does Climameter do that? How is Climameter going to give us the tools we need?
Okay, Climameter is going to give you the knowledge that you need. Then the tool is we have the cure already. This is in the IPCC reports. There are two parts of these reports. IPCC, let's recall it, is the Intergovernmental Panel for Climate Change. So that is the body of scientists all over the world that assess how bad is the cancer of climate change right now. And it's not just assessing how bad it is. Now we have also two parts that are dedicated to the solutions. And one of the cure is stop burning fossil fuels. So that's the first message. Or reduce wherever we can reduce. And then, for example, you go to the doctor, you say like, okay, you have to cure the cancer, you have to do this, and of course you do it. Or if you say like, okay, this is making, I cannot do it because I have other things that I have to solve. For example, international conflicts, okay, or social conflicts that requires you some money, or for some things you say like, I don't have alternatives. For example, for international flights, you have to fly because there is no other alternative. So, and the doctor will say, okay, but there are some things that for sure you can start to do. For example, transition to renewable energy, reduce, have public transport, public transit in your city, and so on and so forth. Many things, many different things. And you do what you can do.
Many things.
The thing is, we are not doing even half of what we should do. And we are not even believing the doctor. But the thing is, Climameter is one of the doctors, right? But there are so many doctors, climatologists, like the entire. You can
the entire
So and so
I don't think you would find a reputable doctor at this point who would say you don't have cancer. I think any reputable, respectable doctor is going to go, you're a sick individual. This guy right here needs help.
Yeah, exactly. So Climameter, to go back to Climameter, is contributing to making this very rapid link between the extreme events and the climate change, and to build awareness in the societies on how climate change is affecting this phenomena. So
that is the other important thing.
Is communication, of course.
Right. So that's the other aspect of this, is not only have you built the model, what the planet would be without the human created climate change, so that we can compare that to the data, what we see, because we do know there is climate change and that we're behind it with the burning of fossil fuels and the creation of an overload of carbon in the atmosphere. But the other thing is that you've made this accessible for people like me, journalists who, professional gossips and loudmouths who are looking into other people's business. And so you make it easy for us. People like the Wall Street Journal come to you. CNN is coming to you. The New York Times comes to you. And, excuse me, I have got to decline that. Somebody has decided to call me right in the middle. I thought I had it shut off. Anyway, so that seems to have been the goal, is to get that message out and get it out quickly, repeatedly, and accurately. So why is that important? Tell me about it. Tell me why you're doing what you're doing. This is important stuff.
So first of all, it's not something that we came up one day and we decide we do Climameter and we communicate it like this. So this Climameter comes from several years now, 10 years of research of an entire team that is based in France, but with the contribution of many colleagues all over the world. And I want to recall that in Climameter, we have institutions from the US, Columbia University. We have colleagues from the NOAA. So we have colleagues all over the world that contribute to Climameter. And the idea is really that we have a pipeline that allows us to be out very quickly. And it is a tool that is not only conceived for communication, but also to communicate among the colleagues, right? So what is the future of Climameter? I think that the important thing to understand is the fact that we provide always the same kind of output, is a unique figure that is the same format for each event. So once you know how to read one, you know how to read all the Climameters, and that's what's very helpful.
Very important.
And there are meters. 1 meter is how much climate change is affecting the extreme events, and another meter is how unique is the event. So these are the meters of Climameter. And then we have sort of charts that shows you the event. So in terms of charts of pressure, temperature, precipitation, and winds, and how this has changed. So this is a unique feature that we have in Climameter, is one single figure that everyone can read, or just with a very little training. And then our report are also, they have a very precise structure. First, there is the history of the events. We are trained as meteorologists, although we don't work in national weather services, but we have training in the weather. So what we provide is a story of the event. This is already important to understand how this a cyclone, how a heat wave forms, and what is the evolution. Then we have we comment on the structure of the event, and we have an important part that is what the IPCC or peer-reviewed literature say about this event. And finally, we talk about the changes that we detect with the Climameter, right? So it's a structure that is, I think, very easy to read, both for the colleagues and for the media. And this, I think, what made so quickly the success of this tool that, as you said, now we didn't expect, honestly, 1 year ago when we start, we didn't expect to be so quickly picked up by the international media. But first of all, let's say that we have done research before going out. So there are several papers, there are several projects piloted by the European Union mostly that we acknowledge in Climameter and that allow us to go out with this product. And then we have a powerful partner in communication. We had two. One is GSCC network, GSCC. It's a network that communicates about climate change, and it handles the communication for us. It also provides us media training. So we are trained to talk with you, with the media, with the general public. And we also
He's done a good job.
Yeah, so and that's definitely very helpful. And then we have the feedbacks, the continuous feedbacks of the journalists, of you guys, of the public, and we are open. We are open to change. We are open to make this an evolving tool, because we are committed to just offer the best communication on climate change, because this is something that goes even beyond our research. We feel the urgency of getting this out, and really everything that we do in Climameter is supported by our own institution, but it's totally no profit whatsoever. It's a free tool. Whenever we do interview like this one, or whenever you see me in the media, we don't receive money, so we don't have conflict of interest. We are doing this because we believe that is an important tool, and is right now the moment to do it. So that's
now is the time.
Now
is the time. The faster we act, the sooner we'll have a solution. The more climate change we can prevent. If you're just tuning in, today I am talking to Davide Faranda, and he runs the Climameter.org, which you've just heard him describe, and you can visit him there. Davide, how can journalists contact Climameter if they want to talk to you? And is it a tool for just anybody, for the average person? How can they use it? So I have two questions there.
Yeah, so the journalists can contact us. There is an email address, and normally if they want to be in the loop of receiving the reports, normally we our partner send out the media information just before we publish it. We have a very short embargo. Sometimes we decide that it's so urgent to get it out that we get it out. And the best way to get in touch is to follow us on X, on Twitter, and on LinkedIn to follow my page, for example. But on X, we have the report out, and this is for the journalists. They can contact us for interview. We also have every press release as quotes from us that help the journalists to write their story immediately if they want, or we are available anytime after the event. And the thing is, normally we have local scientists. That is our strength, because scientists, they can speak the language of the event when it happens in countries that are not French speaking or English speaking. And then we have also the possibility of linking directly, because as you know, each country has its own way of communicating science, which is perfectly fine. And so the local scientists can adapt. And for the general public, we also got feedbacks that our reports are easy to read. We use a plain language that is something that is scientific, but with terms that are accessible for all. And finally, there is another category that you didn't mention, but we are interacting a lot with politicians. They are also asking us for reports and for understanding what's the role of climate change, with the idea that we can make actions of mitigation and adaptations that have to be tuned with the new reality of these extreme events that are becoming more intense, as we see in our reports.
Okay, that is a wonderful thing that you're doing, and it's an important tool, and I think it's very useful. Do you have any other plans for similar work, or is this going to consume you, or just going to keep making what you've got here better? Because it sounds like it's already a very good thing.
So as you can see, this tool is kind of operational already, although we run it really without specific support. So one of the things of this tool that is it runs on the laptop I'm talking now. So it's also very low in terms of carbon emissions. So I don't need to run supercomputer to get out the Climameter reports. Of course, this is a tool that is at a certain point we are keeping to develop, right? But we would like this to become operational in the weather agency or the national center like the NOAA or Copernicus in Europe. So that's our goal, because the things I'm really interested in is science. I'm a scientist, so I want to make it evolve, to make it better. But at a certain point, I want a national agency in Europe or in US, whenever it's needed, to take it for free and to run it and to provide this as a service for the people. So that's what we do with science in general. We increase the knowledge of the world, and what will make us happy is that this knowledge is useful for the humanity and for human beings.
Well, I think you've hit gold then. You have pay dirt here. And if you're listening, NOAA, if you're listening in, get a hold of this guy. Integrate this. Build it into your prediction models. Make it available as widely as possible, because this is important stuff. It's important that we act together, isn't it? We can't individually tackle this. It's got to be a group effort, doesn't it, Davide?
It is, and I can tell you just how many nights and mornings we spent writing reports to get them out as soon as possible and to provide this information to the people. So I'm moved to see that there is so much interest around this tool, and this makes me really feel hope for the future, that we are going to make a brighter future also with respect to climate change, but not only, because Climameter is a communication tool. The idea is that we connect scientists from all over the world also with this tool, with this goal that is providing the best information possible. So it's also something that goes beyond the national borders, beyond the national services. It has something special, this Climameter that we build, and we are very proud of it for these reasons.
Well, we're all one people, and this is just one Earth, and there's only one sky, and we are EarthSky. And Davide, I thank you for joining us today. It's been a wonderful time talking to you. Please, folks, visit climameter.org. Go see the work they're doing. It's important, it's understandable, it's accessible, and it's immediate. He's got reports. They have reports, because it is a group effort. Davide here is just the face of this wonderful effort. Anyway, go visit climameter.org. That should be a clickable link you're seeing on your screen right now, I hope. Fingers crossed. Anyway, if not, you know how to type. Thank you, David. David, again. We will be back on Friday with the Sun News with C. Alex Young, heliophysicist at the Goddard NASA Space Flight Center, and he will be here for his weekly talk with Debbie. David, thank you again, folks. Don't forget to like and subscribe so you don't miss anything. We'll see you next time. Bye-bye.
Bye.